Okay, so we still have just some problems concerning the exam. I'll start by this one. Replace the three forces acting on the plate by a wrench. Specify the magnitude of the force and couple moment for the wrench and the point Pxy where its line of action intersects the plate. So here, if you remember, what was the definition of the wrench? The wrench is defined as a system of force and couple that are parallel to each other. Okay? So what we should do here, we should try to reduce our system of forces acting on the plate into one force and one moment vector that are parallel. Okay? Now, what they want us to find is the magnitude of the force and couple moment and the point of their application on the plate. So we have several unknowns that we should try to find. We have x and y unknown, and we have the magnitude of the couple. For the force, the magnitude can be easily calculated. Why? Because you know that the resultant force is the summation of forces. So F resultant is equal to FA, FA plus FB plus FC. Okay, so it's equal to 500I plus 300J plus 800K. So the first step, as we said, is to calculate the resultant force, and once we have it in as a vector, we can calculate its magnitude as radical of 500 square plus 300 square plus 800 square. Now, next step, we want to reduce the system to a wrench. This means that at point P, we want to have one force, one couple that are collinear. Okay? So at point P already we know what is the value of the resultant force. We know its components. And what we know about the wrench, the main property of the wrench is that the force vector and the moment resultant are collinear. Okay? They can be same sense or opposite sense. What we will know from calculation. Okay? So we do the assumption first that they are, if you want, same sense, or just we say they should have to be collinear, they should have or the same unit vector or opposite unit vector. So how we can uh, write this in an equation? Okay, if two vectors are collinear, then we can say that I can write the moment vector mr vector should be equal to a certain algebraic value, which can be positive or negative, depending if MR and F are same sense or not, times the unit vector of FR. Okay? So what we should do here, we should find the unit vector of FR and say that the resultant vector moment should be along the same line of action. So it can be written as a certain algebraic value times the unit vector. Concerning the unit vector of FR, we
Doctor,
can easily find.
can you repeat the formula, please?
Yes, I will. Okay. What is the definition of a wrench? When we say replace by a wrench, this means that we will replace the system of forces acting on the plate by one force, one moment that are collinear. Okay? So here, for the resultant force, how you calculate it? The resultant force is the summation of forces acting on your body. You have three forces acting on your body. So you know your resultant force. It's Fa plus Fb plus Fc. So you completely know your force in magnitude, in direction, and in sense. Everything is known about it. So then you know its unit vector. You can calculate now its unit vector. Okay? Once you know the unit vector of Fr, since it's a wrench, you are reducing to a wrench. This means that your resulting moment, which is reduced at P, should be collinear with Fr. What does that mean? that the unit vector of the moment vector is the same as fr or just the opposite one. Okay, so you can write then that the resulting moment mr vector, so resulting moment vector is having a common line of action with f. So I can write it as the following. I can say that this vector is equal to the magnitude of the resulting moment, or if you want, let's say the algebraic value, because if they are same sense, mr will be positive. If they are opposite sense, so you can have mr like this, but same line of action, but opposite, then mr will be negative, okay, times unit vector of fr. Okay, so this equation will ensure what? This equation will ensure that fr and m resultant, f resultant and m resultant at p, of course, because we are reducing at point p, are collinear. Okay, so this equation will help us into finding mr. Now, what is the next step to do? I will find the unit vector of fr. For the unit vector of fr, it's equal to 500i plus, okay, so I have so unit vector of fr is equal to 500i plus 300j plus 800k over radical of 500 square plus 300 square plus 800 square. Okay, so in this way I defined the unit vector of fr. Now I found a first relation for the moment resultant vector, but what is the second expression of the resulting moment? How can I calculate if I give you a problem and I tell you reduce the system of forces to point P? What will be your resultant moment? It's equal to what?
We have sorry, we have to calculate the moment of each force on P.
Very good. So now we will say that this vector, which is mr unit vector of fr, is equal to sum of forces about P, okay, and sum of moments of forces about P, and of course we consider all forces moments, and in case we have couples, we add them. Here we don't have the moment vectors, so we just have moment of forces about P. So I will calculate how to calculate moments of these forces about P. The easiest way here is to use the vectorial method. Okay, so I have first FA is passing by point A, so the moment of FA is about P is PA vectorial FA. The moment of FB about P is PB vectorial FB, and the moment of FC about P is PC vectorial FC. Okay. We also have another method. I will do it with you now. Just let us do the first method. So summation of moment about P equals to AP vectorial FA plus, sorry, PA I mean, because we start from the point about which we are doing the moment. PA vectorial of A plus PB vectorial FB plus PC vectorial FC. Okay, so all we have to do now is to find coordinates of points to be able to find vectors PA, PB, and PC. Okay, Now, I will just erase to find the coordinates. For A, it's very simple. A is the origin, so it's 0, 0, 0. For point B is on y-axis, so it is 0, 4, 0. For point C, it has x and y components. Okay, so for point C, I have 6 along x and 4 along y and 0 along z. And finally, for point P I have two unknowns, so I will find the coordinates of vectors, function of x and y. So at point P I have x, y, and 0. So x, y, and 0. Okay. Now I can start to write my vectorial relation. First, look, this is the unit vector of fr, which we calculated together. So I will just replace the unit vector by its expression. So I have mr times unit vector. The unit vector is 0.5051i plus 0.303j plus 0.8081 along k, okay, equals to, first, AP vector, PA vectorial FA. PA coordinates are minus xi minus yj. Vectorial FA, what is FA? 500i. So vectorial 500i plus PB, vector PB is minus xi plus 4 minus yj plus 4 minus yj okay, vectorial FB is 800k, okay. So this is if you want all of this vector, okay. Okay, and finally, for the final component, I have for FC plus PC vector. PC vector is 6 minus x along I, 4 minus y along j. So plus 6 minus x along I plus 4 minus y along j, vectorial f of c, which is 300j. Okay, now once we have this expression, all we have to do is to expand. Okay, I will do the expansion. Here it's easier to do the expansion than to do the matrix method because you have little terms. So you will end up now with a vectorial relation, which will give you 3 equations, because whenever I have a vectorial relation in 3D, I can compare along I, along j, and along k. So I obtain 3 equations with 3 unknowns. So let us do it into steps. So now I will start to expand. Okay. First, I will start by here. I vectorial I, 0. J vectorial I minus k, and I have a minus already, so plus 500 y along k. This is the expansion of the first term. Now I start by the second one. I have I vectorial k. I vectorial k is minus j. And I already have a minus. So plus 800x along j. Now, j vectorial k is plus I, okay, because I jk, so jk is positive. J vectorial k is plus I, and so it is plus 4 minus y times 800. So I will put 800 here times I. Okay. Now for the last term, I have 6 minus xi vectorial 300j. I vectorial j plus k. So plus 300 times 6 minus x along k. Okay. And j vectorial j is 0. Okay. Now I obtained my vectorial relation. The next step is to compare along I, along j, along k. So first, compare along I. When I compare along I, from the first side of the equation, what do I have along I? I have mr times 0.5051. So I will write 0.5051 mr is equal. From the other side, what do I have along I? I have just one component along I, this one, which is 800 times 4 minus y. So I will just put it. This is equation number 1. Now, the second equation will be comparison along. So I will compare now along j. If I compare along j, what do I have? From the first side, I have this component, mr times 0.303j. So it's mr times 0.303, okay, equals to, from the other side along j, I have just also one component, which is 800x. So this is the second equation, equation number 2. And finally, by comparing along k, I get my third equation. So along k, what do I have? I have first 0.8081 mr equals to, along k, from the other side I have 500y plus 300 times 6 minus x. Okay, so I end up with a system of 3 equations with 3 unknowns. Okay, so all I have to do now is to solve it. I can, in order to solve it, for example, I can solve it by substitution, or I can use the calculator, so as you like. You know how to solve a system of 3 equations with 3 unknowns. The 3 unknowns are x, y, and the resulting one. Okay? Any question on this method? Michael, when you reduce two forces, look, it depends on the question. Okay? If I tell you in the exam, I will be clear. If I tell you reduce the system, find the magnitude of the resulting force, you just give the magnitude. If I tell you what is the, I will tell you what I want from you in the exam. I will tell you if I want the magnitude or if I want the angle of the force. It will be clear. Okay?
Doctor,
Yes?
if we have a couple moments, we reduce it to one moment and then we do the position vector from P.
No, if I have this, for example, a force here like this and a force here like this, that constitute a couple.
Yes.
Okay. If you have a couple moment, you can deal with it in two ways. Or you say, since it's a couple, it's equivalent to a moment vector. Yani you say that, for example, here, I will give you a numerical example. If this is 20 newtons, for example, okay? And you know that the distance between the two is 4 meters. Then you say that they will lead to a couple moment, first like this, okay? So how will be your vector? If you do the right hand rule, your vector is along the upward, okay? So this is your couple moment. It's a vertical vector, and its magnitude is 20 times 4. So it's 80 Newton meter. In case you reduce the two force to a moment vector, then when you do summation of moments about P, you don't have to take a vector position vectorial 80. Of course, no. Because already it's a moment. Yani, you know that the moment is a free vector. So when you do sum of moment, you say, in addition to moment of forces, I will add plus 80. That's it. Okay? هلا, the second method, if you didn't replace the two forces by the moment vector, you keep them as two separate forces. You can say that when I do sum of moment, I will take for the first force a point, let's say point D, and then the moment is PD vectorial 20I, and for the second moment you take PE vectorial minus 20I. Okay? ساعتها خلص يعني you calculated the moment of each force about P. But you will get at the end that if you sum the two, you will get 80 K. Okay?
Oh, okay.
يعني or
Vector?
you replace them by a moment vector, and just when you do summation of moment, you add the moment vector. Or you keep them as separate forces, and when you do sum of moment of forces, بتحسب المومنت تبع كل واحد. بس don't do both, انتبهوا بتكونوا حسبتوه مرتين in this case. Yes.
الفورمولا اللي طبقناها هلا
Yeah.
تحت يعني المومنت الأساسية is equal to لا المومنت about P is equal to the moment about R multiplied by the unit vector of
Yeah.
the resultant
هيدي من وين
force.
اجت الفورمولا؟ هيدي اجت من الديفينيشن of a wrench. اوكي هيدي منا فورمولا. هيدي اذا بدك if you understand what is a wrench, you know how to write. What is a wrench? A wrench is a reduction of a system of forces to one force, one moment that are parallel. That's it. If you know the definition of wrench, you can write that the resulting force and moment at P, which is the point of reduction, will be collinear. شو يعني collinear؟ يعني they have same line of action. يعني I can write the moment vector as a certain algebraic value mr times unit vector of fr. Okay? يعني هيدي جاية من the definition of wrench. Because it's a wrench, I want to reduce to a wrench, then the final reduction is one moment, one force that are parallel. This is why I can write this term. يعني هيدا الترم لقيته لأنه قالوا لي it's a wrench. تاني term هو العادة إنه a resulting moment is what? Is summation of forces, a moment of forces about the point plus couples. بس بما إنه ما عندي couples here, so I just have summation of the three forces about P. Okay?
Yeah.
Okay. So now, هلا هن they used another method in the solution. I will explain for you what they did. Instead of taking the vectorial product, هن قرروا يستعملوا right hand rule. Why here it is feasible؟ لأنه the forces are simple relative. Okay? نحن if we want to reduce to point P, if we are reducing to point P, then the moment about P will have three components. What are these three components of moment about P? أنا كأنه P عنده 3 axes X, Y and Z. يعني أنتوا بس تعملوا sum of moment about a point حيطلع لكم 3 components. شو هن ال I, J, K component؟ ال I component حيكون ال moment about a axis X prime passing by P. Okay. المومنت about J حيكون المومنت about Y prime axis passing by P. والمومنت about K حيكون المومنت of Z prime axis passing by P. فهن قالوا لأنه الforces are simple ليش تعمل vectorial method? I can use the right hand rule. How to do this? I start by summation of moment about X prime. ال FA بتعمل moment about X prime شيء؟
No.
No.
لأنه
Why?
it's parallel to it.
Because it's parallel. ال FC is doing a moment about X prime.
No, it's
No,
positive.
because it's intersecting X prime. The only force who is doing moment about X prime هي مين؟ هي ال FB. مظبوط؟ So to find the moment of FB about X prime, what should I do? I should do 800 times this distance, perpendicular. Hey, perpendicular from between force will X prime. What is this distance here? It is 4 minus Y. Okay, so I can say, كان فيني دغري أقول if I do sum of moment about X prime, it is just equal to the moment of FB. عملوا right hand rule. هالmoment positive أو negative? If you put your 4 fingers like
It's positive.
Positive.
exactly, it's positive. Okay, very good. So I can just write now that if I do sum of moment about X prime, I have plus 800 times the distance, which is 4 minus Y. Okay, and this is equal to what? This is equal to the x component of the moment. What is the x component of the moment? It's mr times 0.5051. So إذا بتلاحظوا رجع طلع لنا نفس equation 1. Okay. Now if I do the same about y, sum of moment about y prime, what do I have? This is y prime axis. First, FC عندها moment about y prime? No, because it's parallel. FA عندها moment about y prime? Also no, because it's intersecting. So the only force doing a moment about y prime is also FB. But now, what is the distance I take? I take the distance between y prime and FB, this distance. Okay, what is this distance? طلعوا بالفigure. What is this distance? It is 6. It is just x, مظبوط?
Yeah.
From here to here is x. So وعملوا right hand rule. It's positive moment or negative moment? You put your right hand like this. Your palm facing y prime.
Positive.
Positive, exactly. So it's plus 800 times x along j. Okay, so this is equal to 800x equals to the component of mr along j, which is 0.303. So it's mr times 0.303. So also we have obtained same equation 2 again. And finally, for sum of moment about z prime, I have, this is z prime. If I look at my figure, okay, I have FB parallel to z prime, no moment about z prime. Now for FC, okay, FC is at a certain distance from F prime. What is the distance from z prime? So the distance between z prime and FC is equal to what? This one, which is 6 minus x. So now, to know if it's a positive moment or negative moment, do the right hand rule. If you do the right hand rule, you will see that it's a positive. Positive. So it's plus 6 minus x times 300. And for FA, is FA producing a moment about Z prime? Look, this is FA.
Yes.
Yes, because
Yes,
you
it
have
is.
a certain distance. What is the distance between them? It's Y.
Why?
It's Y. So, and if you do the right hand rule, try it, it's positive. So plus 500 times Y equals to the component of moment along K, which is MR times 0.8081. So this is equation number 3. And if you compare with our previous system, we obtained the same three equations. So of course, when solving, we'll get the same result. Okay. Any question on the second method?
Yes, doctor.
Yes.
Doctor, if we thought about calculating the sum of moments about A, يعني applying the old method كأنه I have one unknown منه X and Y.
Look, I will tell you why no. Because here, they want you to reduce to a range at P. Yani they told you that I want to find the coordinates of point P in a way to have a range. To have a range, I have the force and the moment that are parallel. How you will use this information? Okay. If you want, you are saying to me, you want to reduce at A first and then move your force if you want. This is what you mean?
First, we used to reduce everything at A and then find X and find Y, if you remember.
Yes, I understand what you are saying. Yes. Okay. Look, in principle, yes, it's not wrong to do this. You can do it. Okay. So what you will do is you can say that I will reduce first at A, but look, it is little bit complex. You know why? Because when you have a force and moment that are not perpendicular, okay, you should project your moment into one component parallel to F and one component that is perpendicular to F. Yani in 3D, this will make things complex. Okay, so theoretically, yes, you can do it if you want. It's feasible, but it's difficult for calculation as geometrical calculation. Okay, so whenever I advise you, whenever you have a 3D problem, okay, especially if they say a range, when they say a range, you can use the additional property that the force and resulting moment final are parallel. This will give you an additional
Yes,
equation that will simplify your calculation. هلا the other method كمان مفروض تزبط, but it is more complex. I will tell you why. Because look, here when you reduce to a resultant force, هيدي الفورس عندها XYZ component, and when you find the resulting moment كمان حيكون عنده X, Y, and Z, بس منن perpendicular. So what you should do here, okay, for example حنعتبرهم هيك. What you should do, you should project the moment on the force. Find one component that is parallel, one component that is perpendicular, okay? And now, when you want to displace your force, it will be displaced on a line of action in 3D. يعني منا along X و Y بس. يعني you will displace in this way here, for example, to remove this moment. تخيل إنه أنت this is the force and you want to remove this moment, okay? You want to displace it in a way to create this moment. يعني لصوبنا. You should displace it towards us. And يعني حيكون ال point of reduction in the space. كيف ترجعي بتلاقي P؟ ترجعي بتقولي إنه once I find this point in space, the line of action of the force, if I displace it on its line of action, بتضل range, يعني nothing will change. ساعتها بدك تلاقي ال intersection of the line with the plate. ما بعرف إذا فهمت علي. I will repeat. Let me open a new session and repeat لأنه I have less than 1 minute. Okay? يلا, I will re-explain again.